Today we're going to be doing problem number 5, longest palindromic substring. The problem statement is as follows. Given a string S, return the longest palindromic substring in S. Now there are a lot of optimal solutions for this problem, but I'm going to be showing you the most straightforward one. So let's remember that you can always create a palindrome by expanding outwards from the center. So we're going to use this idea to build our algorithm. First, we're going to go through each letter of our input string, designate the letter we're currently at as the center, expand outwards from that center to create a longer and longer palindrome, and meanwhile, try to keep track of the longest palindrome we've seen so far. So let me show you what that actually means with an example. Let's say we have an input string like babad, and we're going to start at the letter B. So we're going to initialize 2 pointers, a left pointer and a right pointer at this first letter B. And we're going to check if the left and right match. They do match, so we're going to say that the longest palindrome we've seen so far is simply the letter B, which is by default a palindrome, right? So we're going to now adjust these pointers to try to make the palindrome longer. The left pointer is going to basically move one step to the left, and the right pointer is going to move one step to the right. But unfortunately, we see that the left pointer falls off the edge of the word. So we've actually exhausted the possibilities for this palindrome and have to move on to another possibility. So let's just delete these pointers and start them off anew with the letter A. So we're going to initialize a left pointer and a right pointer at this position. And then we're going to check if they match, which they do. But since it isn't longer than the longest palindrome we've seen so far, they're both of length 1, we're not going to change our letter B here. So we're going to do exactly what we did before, which is basically move this left pointer to the left by 1, and this right pointer to the right by 1. So notice that B and B match here, which is great because that means our palindrome can be extended. Our longest palindrome so far is actually going to be B, A, and B. So we have bad as our longest palindromic substring so far. That's great. Let's try expanding this even more. Well, the problem is if I try to bring this left pointer to the left by 1, it's going to fall off the edge of the word. So we actually can't expand this palindrome even more than it already has. Unfortunately, we're going to have to move on to the next candidate. So we're going to delete these pointers, and then we're going to initialize a left pointer right here and a right pointer at the same spot. Now they both match, which is great, so we're going to move the left pointer right here. We're going to move the right pointer right there. And again, they match, which is awesome. Now we have ABA, right? But that doesn't beat what we have so far, so we're going to keep going. Left pointer is going to move over here. Right pointer is going to move right over there. Now we have a mismatch, so we actually have to stop the search right here and move on to the next candidate. So our left and right pointers will start over at the letter A. Now we see that, of course, they both match, so we're going to move the pointers. And now we actually see a mismatch. So we have to stop our search and start over at the next candidate. Now the left and right pointers will start over at the letter D. Notice that if I do even one iteration where I move the pointers, the right pointer will fall off the edge of the word. So at this point, we've finished our algorithm because we've went through the entire input string, considered each one as a possible center, and tried to expand outwards to basically create the longest palindrome we could. And at the end of this entire process, we found that BAB was the longest palindromic substring we could create, which is actually one of the possible correct answers. So this is great. Our initial algorithm can work with one of our examples, but it actually doesn't work with an input string like CBBD. Let me show you why. So let's say we start with the character C. We initialize a left pointer and a right pointer at C. Now, of course, they match, so we're going to say the longest palindromic substring is C. Now, if we move the pointers, the left one is actually going to fall off. So we're going to have to stop the search and start over. Which means that the left pointer will be right here, and the right pointer will be at the same spot. If we move the pointers any further, we're going to see a mismatch between C and B. So we're going to actually have to stop and move on to the next letter. Initialize the same pointers, but again, there's a mismatch if we move them, so we're going to stop and move on. Oops, need to delete that. Okay, so when we move on, we're actually going to start over at D, and if we actually do one iteration, we see that the right pointer is going to fall off. So essentially, we've finished processing this entire input string, CBBD, and we found that the longest palindromic substring was C. Unfortunately, just by looking at this input string, we know that's not right, because the longest palindromic substring is BB. So it turns out that our algorithm doesn't work for even palindromes. And that's because one fundamental assumption behind our algorithm is that we have a center to begin with. But with even palindromes, that's not always guaranteed. In fact, that's never guaranteed. With a string like BB, there is no center. So instead, to adapt our algorithm to work for cases like these, we have to consider the possibility where there is no center in the palindrome. And in those cases, we're just going to be matching the two middlemost characters. So for example, let's say we're iterating through this input string like usual, right? That stays the same. And let's say we're currently considering this first B. So we're right here. Now, instead of choosing B as the middle, and then expanding out from the center with a left pointer at C and a right pointer at the second B, we're going to be doing something a little different. We're going to be initializing a left pointer at this first B, and then a right pointer at the second B. This makes it so that we effectively ignore a middle element. Because remember, even palindromes don't have a middle element. So if we actually do something like this and start proceeding as normal, we're going to actually find that BB is the longest palindromic substring for this input. So let's say that L is at the first B, R is at the second B, see if they match. They do match, so we're going to change our longest palindromic substring to BB, right? So we're going to actually expand outwards like we've been doing before. If we try to move L to C and R to D, we find that there's a mismatch, so we stop there. And the algorithm basically continues like normal as we scan throughout this entire input string. So the catch here is that we're still going to be scanning through every letter of the input, but we're going to be checking for two possibilities. The possibility that the palindrome is even, and the possibility that the palindrome is odd. If the palindrome is odd, then we're going to initialize the pointers in one way. And if the palindrome is even, we're going to initialize the pointers in another way. So let me show you what that means in a more concrete way. So again, let's say we're at B. Case 1, the palindrome is odd. So we're going to initialize L and R at the same spot. Let's say that spot is I. We're going to initialize L and R at I. And then we're going to expand outwards from this initial position. So let's say instead of being C, this was actually B. Right? Just imagine that this was actually B, which would mean the longest palindrome so far would actually be odd, right? So in that case, we could actually just initialize the left and right pointer at the same position and expand outwards like we would normally do, and that would work. But case 2, if the palindrome were even, then we're going to initialize it another way. We're going to say something like this. The left pointer starts at position I, like we would normally do, but the right pointer starts at position I plus 1. And then we're going to start comparing them like we usually do. The reason why we change the initialization here is because we don't have a middle element to expand outwards from. So we're essentially skipping the step where we initialize both pointers at a middle element and pretending like we're already finding two pairs, or rather two letters that can form a pair on both sides of the palindrome. And then after that, we expand outwards like we usually do. So hopefully that makes sense. And if it doesn't, I'll start writing the code soon. So that should help you basically understand the concepts a little better. Okay, so the first thing we have to do is write a helper function. This helper function is called expand, and it helps us match characters as we're expanding from the middle element in our palindrome. And this is going to take a couple of parameters. We're going to say A, B, J, K, and S. Okay, I'm going to explain more about what that function does later. Let's write the main function for now. And actually, this function should not be there. It should be here. Okay. So first we're going to iterate through the input. Nothing surprising there. And then we're basically going to keep markers to keep track of the longest palindrome we've seen so far. We're going to call them A and B. And we're going to update them with our expand function. So let me explain what I'm doing here. This first line is passing in our current value of A and B, which basically means telling the expand function what the longest palindrome so far is. And then we're going to start initializing our left and right pointers, which I just call J and K here. J is the left pointer, K is the right pointer. Now, this is the case where we have an odd palindrome, right? Odd palindrome. This is the case where we have even palindrome, right? Notice, I plus 1. And S is, of course, just our input. So remember, we have I plus 1, and I. Those are the two cases we had to consider. And then after that, we just have to return the longest palindromic substring, right? So that's just as simple as string slicing. Okay, now let's try writing our expand function. We're going to say while j is greater than or equal to 0 and k is less than the length of s, and sj equals sk, So all this is saying is while our pointers are still within the bounds of the string, and we have matching characters that can help us make the palindrome longer, do the following. We're going to say if k minus j plus 1 is greater than b minus a plus 1, a equals j, and b equals k. So what is this? This is saying if we discovered a palindrome that has a length greater than the greatest palindrome we've seen so far, then we're going to update the greatest palindrome we've seen so far to the length of that recently discovered palindrome. This is all these couple of lines are doing. Now, we also have to do one more thing. Once we update the longest palindrome seen so far, we're going to have to move our pointers. J is going to have to move to the left because it's the left pointer, and K is going to have to move to the right because it's the right pointer. And then we're just going to return A and B. So that's actually it for this algorithm. Let's see how it runs. Oops. Okay, so we actually got a working algorithm here, and let's analyze the time complexity. So we have one for loop here that's linear time. We're going over the entire string. But we're also, within this for loop, going into the expand function. Now this expand function has a single while loop that is big O of n time, right? Because in the worst case, we could have a middle and then expand outwards until we basically cover the entire string. So the expand function is big O of n worst case, which means that our worst case overall for the longest palindrome function is quadratic time, right? Because we have a for loop here and a linear time algorithm there. Now, we may have two instances of calling the expand function there, but we call one and then the other. So you would be mistaken if you called this cubic time, right? These are actually just added together instead of multiplied. But anyway, we have a quadratic time algorithm here, which is optimal in terms of overall time complexity anyways. So I hope this video helped you, and please don't forget to comment, like, and subscribe if you want to see more videos from me. Thank you.